Electrochemical machining or ECM. The ECM process is reverse of electroplating. In the sense, in electroplating, the workpiece is cathode and the material which is used for plating over the workpiece is made as the anode. But in the case of ECM, the workpiece is made as anode, that is, it is connected to the positive terminal, and the tool is made as the cathode. In construction, the workpiece is fixed over a fixture and which is housed inside a container which is made of stainless steel material and which is connected to an electric supply, that is positive terminal of an electric supply, and the voltages is ranging from 2 to 30 volts and having a high current rate of 500 to 24,000 amperes. The tool is made as the negative electrode and which is having specially made passages to pass the electrolyte to the metal removal region, and there will be a servo controlled feed system to maintain the constant gap between the workpiece and the tool. The commonly used electrolytes are sodium chloride, sodium nitrate or brine, and we are ensuring a continuous supply of electrolyte using a pump, and a filter is used to filter out the unwanted materials, and a heat exchanger is used to remove the heat or the heat generated by the process and bring it down to the normal temperature. The process of ECM is explained with this picture, and this work is iron or steel. Then the tool is an electrically conducting material, and the electrolyte contains NaCl and H2O. When the work is connected to the anode and tool is connected to the cathode of the electric supply, first the electrolytes is ionized to form sodium plus ions and chlorine minus ions, and H2O is ionized as H plus and OH minus ions. The H plus ions will move towards the cathode and it will take away the electrons in the cathode and forms the hydrogen gas, and the hydrogen gas is removed from the system. Similarly, at anode, the iron atoms will come out and it will form a reaction like this. The iron atoms will be ionized into Fe2 plus 2 electrons, and this Fe2 plus is combined with the chlorine ions and it will form iron chloride, and some portion of this ions will form with OH minus and it will form iron hydroxide. The sodium plus ions combines with the OH minus and it is forming NaOH, and that will be carried along with the electrolyte. And the FeCl2, that is the iron chloride and the iron hydroxide, which are formed, and these are heavier and it will be precipitated and it will be deposited in the form of sludge. The sludge will be either deposited inside the chamber itself or it will be carried away with the electrolyte and it will deposited at the bottom of the electrolyte chamber. Thus, the metal ions are constantly removed from the workpiece, and if we are maintaining a shape on the tool and we are maintaining a constant gap, so the shape of the tool will be produced over the workpiece. Some of the application of ECM are die sinking, then 3D profiling, trepanning, that is the making of large holes, and drilling operations. The process gives the highest chip removal rates with a reasonable surface finish, and these are generally used in electrically conducting materials, and some few applications are there in the field of aerospace, in the manufacturing of aircraft engine parts, turbine plates, turbine nozzles, etc. Thank you for watching.